Okay, I just wanted to take you through a quick overview of the cerebral cortex. This is something that is in your textbook. You might hear some background noises because I'm at home and the light is kind of going up and down and up and down. I have a lot of lights in my kitchen, and I'm doing this at night. But anyway, it doesn't matter. Just listen and take notes. I'm teaching this exactly like I would teach it in class, except I have the luxury of being able to write things out in advance. So if you need to pause the video to write this down, or to write down any notes, please do. So as I said, your textbook goes over the cerebral cortex, so I wanted to go over that with you. It does a little bit of a quick job doing it, so I just wanted to fill it in a bit. And sometimes it's easier to hear it rather than just to read it. And we're also going to draw it out, so that will also help in understanding what we're talking about. So the cerebral cortex is my ice maker. The cerebral cortex is the outer layer of the brain. So the cerebral cortex is the outer layer of the brain. Okay, if you've ever seen a brain, it's got a lot of wrinkles. It's the part of your body that you want a lot of wrinkles. See, the more wrinkles you have, the better, they say. So I'm just taking a lateral view or a side view. I'm drawing a side view of the brain right here. So, and I've drawn all these like little wrinkles. So if you've ever seen that, that outer layer, that's what we're talking about. This is cerebral cortex. So it's the outer layer of the brain. It constitutes 80% of the brain's volume, right? And also takes 80% of the blood that's flowing through the brain. So it's an extremely important part of the brain. They say that, I've read that if you iron it out, I've read this in a textbook, if you iron it out, it would measure 2 feet by 2 feet. Not that anyone would iron out their brain, but it just shows you there's a lot of information, a lot of material in that area, in those folds. Okay, so that's the cerebral cortex. We're talking about the outer layer of the brain. Again, this is a side view. It's a left lateral view or left side view, as if the person is looking this way. Okay, so we're going to draw it that way as well. Now, the cerebral cortex has 4 parts to it. They call the parts lobes. Okay, so the cerebral cortex has 4 parts to it, 4 lobes. So again, if you're just taking notes, and this is how I read your book and I just took notes, and so that's what I'm explaining it to you. This is sort of like if I were in college, how I would go through a textbook and take notes on it. So again, it's easier. The book is going to be much better. I'm just drawing it freehand. So, but it's nice to draw so that you get a sense rather than just looking at something. If you create a drawing for yourself, you kind of understand where things are in relation to each other. So I do encourage you to draw things out for yourself. Okay, so again, left lateral view. So this is as if like the person's nose is somewhere over here. Okay, so the person's looking that way. So the 4 lobes, or the 4 parts of the brain that are called lobes, we're just going to do these divisions. Okay, so 1 division there. This is very rough. Again, look for your text if you want to do this more accurately. And roughly there, going there, right? This is very rough. Okay, but we're drawing the 4 lobes so that we can see where they are in relation to each other, so that you're not just memorizing. You understand where things are. This lobe here, before this line, right? So this whole area in here is going to be the frontal lobe, very nicely named. Oops, sorry, ran out of room. So the frontal lobe, right? So the frontal lobe, and I was able to prepare these in advance. So the frontal lobe, right? This is executive functions and decision making. Okay, so the frontal lobe is for executive functions and decision making. Okay, so the frontal lobe, which is basically right behind your forehead, right here, is executive functions and decision making. So executive, like an executive in a company, they make the decisions, right? So This is for decision making. So what are you going to do? How are you going to plan things out? There's a lot of decision making in planning, and that's all going to happen in the frontal lobe. So when we see that you are planning something, we tell you to plan something out, plan out a project. And if you were to take a look at where the blood was flowing, the blood would be flowing through the frontal lobe. You would be using your frontal lobe. For practical application, some people some researchers have found that people with ADHD do have differences in their frontal lobe from people who do not have ADHD. And as we know, ADHD is not an issue of intelligence. You can be highly intelligent as anyone with ADHD, but there might be an issue with planning. Okay, so in our day-to-day, in our culture, there's a lot of planning involved. You could do your homework, but if you do not pack your homework, then you won't get credit for your homework, right? If you're going to school in person. So our culture has a heavy emphasis on planning. So somebody who's unable to plan might run into difficulty, especially in certain jobs or in school. Okay, so that's your frontal lobe, which we had drawn. I'm going to bring this back again. As we head back, right, from the frontal lobe, I'm going to go in this direction. As we head back, right over here, this area is the parietal lobe, P-A-R-I-E-T-A-L. P-A-R-I-E-T-A-L. I'll probably do this again. If I do this again, I won't do this at night because I think the light is going up and down. It's kind of trying to light this up, and I have so much light behind me. But the parietal lobe, P-A-R-I-E-T-A-L. Okay, the parietal lobe is skin sensations. Okay, from the opposite side of the body. So the parietal lobe is skin sensations from the opposite side of the body. So your text will talk about the fact that you have two halves of your brain. It's one brain, but you have a left side and a right side, and they call it the left hemisphere and the right hemisphere. Well, what we notice is that the left side controls the right part, the left side of the brain controls the right part of the body, and the right part of the brain controls the left side of the body. Okay? So I'm bringing this up with parietal lobe because if you feel someone pinching you on the right, then you're going to show stimulation on the left parietal lobe. Okay? So that's one of the functions. Some textbooks will also say it's spatial orientation or spatial location, so where you are in space, or where you are relative to other things. So an example of this would be if you park your car at the mall, are you able to find it again? Do you understand like where you are located in space and where you're located relative to your car in a certain space? Some people can't, but if you can, then that's good, right? So some people need to work on it a little bit more, just like all the functions. Okay, so that's the parietal lobe. Let's go back to our drawing. So we're drawing this out. Okay, so as we move back, my cap, back from, or down, right, down from the parietal lobe, we're going to have our occipital lobe. O-C-C-I-P-I-T-A-L. O-C-C-I-P-I-T-A-L. Okay, so the occipital lobe is basically vision. Okay, again, draw this again here. So again, in my notes, I would put down that the occipital lobe is vision. You can kind of remember it because OC, the word ocular, right? It also has to do with vision. So the occipital lobe is vision. So if you have damage or if you get hit in the back of the head, there's a saying that you see stars, right? You might black out. I might not be able to see anything for a little bit. So the occipital lobe, that's one way to remember that the occipital lobe is responsible for vision. Okay, and then we're going to move on to our last lobe. Okay, our last lobe is right there. Okay, and that lobe is the temporal lobe, T-E-M-P-O-R-A-L. Okay, so your temporal lobe. And the temporal lobe is hearing. So the temporal lobe, it's a regular night in my house tonight, so you might hear my daughter come down the stairs. Okay, the temporal lobe is hearing, right? And they will also frequently include the understanding of speech, because there's an area included in the temporal lobe. So the temporal lobe includes Wernicke's area. Wernicke, Dr. Carl Wernicke, was a physician who discovered that one of his patients who had damage to a specific area could not understand speech. So they named it Wernicke's area after his discovery. And it's a very specific area in the temporal lobe for understanding speech. Okay, so those are the 4 lobes of the brain that they go through in your book. One of the important things to realize with the with understanding where the lobes are, sometimes, let's say for example, somebody has brain surgery or they have a car accident and we want to assess brain damage, but you don't want to do anything too invasive. You don't want to go back in there and open up the skull or anything like that. So what you might do, one option is also to do testing, right? So if we know that certain areas of the brain are responsible for certain tasks, like in terms of organization, like putting all these pegs in a board and then taking all the pegs out in order, that would be organization, and it would be a very painless way to see if there was any issues with the motor areas of the brain or the frontal lobe. Also, there's a great example in a textbook about somebody being in a car accident, and if you can hear your if you don't recognize your mother when she comes to see you in the hospital, but you can recognize her once you hear her voice, then you know that the occipital lobe is probably damaged, or the part that has to do with vision, which is the occipital lobe, is damaged because you didn't recognize her when you saw her. But the temporal lobe is intact because you were able to recognize her once you heard her voice. So knowing these things kind of helps us to realize where to look when we're looking for damage and how to help people who might have had damage. Okay, another area of the brain is called the limbic system. Okay, so actually we're going to go a little bit beyond the cerebral cortex. We're only going to go through 2 structures. So the cerebral cortex, again, is the outer layer of the brain. It's 80% of the brain. But there's more to the brain than that. There's an area underneath the cerebral cortex. So in that area is called one of those areas is called the limbic system. And I'm drawn to bring this up because there's 2 brain structures in the limbic system that people are extremely interested in, right? So, and I think you'll see why. And one of them is called the amygdala. Okay, so this is underneath, roughly under your ear, like through here. So right about here, right? So the amygdala, right, you've got the amygdala, you've got 2, one on both sides, so you have 2 total. So you have a left amygdala and you have a right amygdala. You probably never, unless you study the brain, you probably haven't heard of it. The word amygdala is derived from the Greek word for almond, so that gives you a sense of the size and the shape. Some other textbooks will also refer to it as a pea-sized or pea-shaped structure. And the reason why the amygdala is such a point of interest is that it's the emotional center of the brain. So if you're studying the brain in psychology, you're going to come across the amygdala. Okay, people have been studying this. I mean, if it's the emotional center of the brain, it's going to generate a lot of interest. Okay, so the amygdala, so again, roughly about here, pea-sized structure, emotional center of the brain, particularly rage, right? So they have found that, you know, if you damage the area, it can cause rage, and if you remove the area, it can remove the rage, right? Or if you damage it enough, it can also remove the rage. So and then we have the hippocampus, which is the second area. Also, the amygdala, if you look at it in reference to one of the syndromes, a syndrome called Kluver-Bucy syndrome. Kluver and Bucy, I think Kluver was a neuropsychologist and Bucy was a neurosurgeon. And they took a look at it in a monkey. And that's part of how we know, it's through their work. And then later on, decades later, they started looking at it in humans. So that, you know, people would have damage to the amygdala, and then there would be certain symptoms that would come up. Okay, for humans, it might be what they call placidity or placid, like Lake Placid. They're very, very calm, so they don't overreact. That's possible. So again, it's the emotions. You're having too much or too little. You know, if it's damaged, it can go one way. It can go the other way, depending on the damage, the extent of the damage, and the location of the damage, and also over-sexuality. Again, related to the amygdala. Okay, the hippocampus, right? So this is learning and memory, and I just went like this because the hippocampus is kind of shaped like a seahorse. So it's Greek, right? Uh-oh, my S got smudged. But it's a Greek word for seahorse. So you've got your amygdala, and then you have the hippocampus sort of wrapping around it. And the hippocampus is learning and memory. So this is amazing, actually, from a psychologist's point of view. The fact that you can have an area that's the center of emotion for the brain, and then you have the learning and memory area right next to it. And I think, you know, from experience, you can see that would be true, that you could see that relationship experientially between learning and between emotion. And then we see it structurally in how close those two structures are. So for example, like in my teaching, I've seen students who are so emotionally distraught that they can't learn, and they tell me that they can't even sit through class, because if they sat through class, they can't be there because something just happened. Someone just died, or there's some kind of trauma happening, and I believe that. Right? If you could be there and not be there because your emotions, like you can't even hear anything because your emotions are running wild. And so learning and memory can't happen at that point. And so, that's a very important, that's kind of an easy way to remember that these two structures in the limbic system are so closely related because you've lived through that. We also see, especially when we're looking at PTSD, how if something is extremely emotional, it can burn its way into your memory also. So that can go either way. It could either totally make you forget everything if it's so emotional, so traumatizing, or it could burn its way into memory that you can't get rid of it. So, again, those two come up in different psychology classes that you're going to take in the future, hopefully, if you will. Okay, so that's it. If you have any questions, please contact me. Yeah, that's it. Bye.